Okay. Hello, everyone, and thank you for joining DataCon LA 2022. Welcome to the track Emerging Tech. My name is Tanmay, your host, and Apurva is your co-host. And please keep your phones on silent while the session, and don't hesitate to raise your hand if you have any questions. This session is currently streaming via Zoom and will be recorded, and it will be available online in a few weeks. Today, we have a guest, Mr. Razwan Nistor, and he will be talking about the title, Practical Solutions to Complex Supply Chain Problems. Without further ado, I'll hand over this to my speaker and thank him for being here.
Thank you. Thank you so much for making it to the end of the day. And to the organizers here, I think it was a great conference overall. Looking forward to next year. I feel like we're getting back into the stride after a long COVID break. Certainly, we started traveling a lot more, visiting clients, getting back to in person, and that's been a great trend. So we're going to talk about data science applications and some analytic solutions in supply chain, but what I really like to focus on is how we build a data function within these organizations to get solutions like this to stick. So we're going to do forecasting, we're going to do some machine learning, we're going to talk about network optimization, but the challenge that we face with a lot of our clients and organizations that we work with is how do we really get companies that are in Excel, they're not new age startups, they're not on the cloud, how do we really get executive data functions to stick with practical sort of solutions in the supply chain space, since it's been such a critical area recently. So who are we? I work for a company called Keyrus. We're a data and analytics consulting firm. We have about 3,000 people worldwide. We're based in France. We do everything from data engineering, visualizations to data science. And how do I scroll down? Oh, there's that beep again. Oh, okay. So it's the old school scroll. I should have brought transparency slides like in the old days. We could have switched those out. And we work across cloud, and we're pretty tool agnostic. We like to bring data solutions to a lot of the companies we work with. And we operate in several sectors: CPG, retail, finance, manufacturing, all of these things. So supply chain is obviously pretty critical in manufacturing supply chain or retail. But not to say that executive data functions across other organizations are not equally important. We work with a variety of solutions. We like to think of ourselves as a technology agnostic consulting firm. Whether you're on Azure or AWS, Tableau, Power BI, that's great. We'll work with what we have. But we do go to market with a few of the tools listed here, and I'll talk about why these are important in the space. So supply chain in particular, obviously COVID disrupted everything. So in 2021, 2022, we're still feeling it. The state of supply chain in every metric or KPI that you try to bring to the table has just been off the charts, awful in every way imaginable. Most specifically for a lot of the clients that we work with, disruptions in shipments, late shipments, sourcing, manufacturing, getting the right raw materials has just been up off the charts. Number of shortages obviously is going crazy, but it feels like it's kind of been stabilizing in the last like 3 to 4 months. I feel like we kind of hit the peak and we're getting a little bit better. And especially on shipments, and we'll talk about why that's critical as a business function for a lot of these companies. Late shipments is very disruptive. And when we talk to executives on what these companies are struggling with in their efforts to solve complex supply chain problems, 53% of executives state that they aren't treating data as a business asset. Really, how are companies swimming in data? We're getting IoT data. We have data from our ERPs, like flooding every inch of our transactional systems and reporting systems. How are we not treating data as an asset? There's something wrong in the translation, taking raw material like data and turning it into something actionable that returns a bottom line for the business. And 93% of executives identify people and process around that. So while We're going to talk about some solutions in supply chain with a focus on some cool data science sort of use cases. It's really coming down to the people and process and what are some of the organizational structures and functions we can leave behind to enable organizations to really overcome these obstacles. And as consultants, it's easy for us to sort of go into a lot of different companies and see trends and some of the things that we see and we try to almost preach, I would say, not quite so openly because people don't like to be told what they have to do, but subtly is really to stand up, I think, the data capabilities and the data function that encompasses like the people, process, and technologies, and we'll really see what this means. So people in particular, and I'm talking like some, maybe not like, like the FANGs of the world, but some other large companies, Fortune 100 companies, really have very skilled people at doing their job, but they don't have the right skills to work with large volumes of data and do real analytics. They're still in Excel, and I'm talking like very well-known brands and companies that we work with manage their supply chain and their application processes in Excel. It's like it's insane to me that this is still going on. But that's really what it comes down to. In terms of processes, then nobody has ownership over the complete end-to-end. It's still fragmented. It's like by email and it goes to this person and then they work on this Excel and then they upload it maybe by email to another system. And in terms of the technologies, well, there's a ton of tools in a lot of organizations. There's no like orchestration amongst these processes to really hit the efficiencies that we're looking for. And in particular, this is what we'll kind of lightly touch upon later, there's no governance around these processes. And there's no like way to make a sustained ROI initiative around the data function. So we can, as data scientists, go in there and do a cool use case with machine learning, but how do we repeat that process? How do we make that function stick? How do we get this be used on a day-to-day impact, the bottom line of the organization? It's a little bit tricky. So we focus really on enabling the people and the tools, and that's great. And we'll talk about some practical use cases and what we're trying to leave behind in addition to just the analytics in this case, because I think all of the stuff around the analytics is going to be define the success story. So really the goal of this talk is to, yes, solve some, I think, complex supply chain problems, but in such a way that we can leave some of these large organizations with really a data function that they can use and go forward. So in data science, everyone wants to do data science. Tam May is talking to me. Everyone loves machine learning, and that's great. We can use a lot of machine learning and data science and clustering and forecasting to address, I think, there's like many use cases across a lot of businesses in optimization and who are my customers and where do they live and what's my ROI. That was like the big one before COVID. Everything switched to the sort of processing side, which is why the use case and the practical applications that I'm going to talk about are more on the process optimization side, just because supply chain is such a critical area. And the first thing we start with, and I think if you're in the room for Keyrus' talk from Enki, when he was talking about building up the capabilities of a data function within an organization, that top-down works, right? So top-down means from the executives, they have in their mind, most CEOs, most C-level executives have in their mind some ideas on how to grow the business, how to protect their margin, how to manage risks. Like this is what their vision, this is the vision of an executive, is to grow the company. So they know some practical ways specific to their company and their business on how to do this. And it's up to us to sort of take that vision and build it out, I think, in an initiative. So we try to put in place these playbooks, which speak to answering a business use case at the end, but yes, along the way, building some of this data function within the organizations. So when we get tasked with questions along supply chain in particular, for example, tell me, how much inventory I should hold in this month of this product and my demand, which is like very common sort of base use case. In order to do that, consecutively across the organization, we like to break it down into a series of smaller use case steps that collectively add up to an initiative and build a capability of an organization to answer this on a continuous basis. And it may start with like bringing your data and forecast your customer demand. It's going to start with your demand. You can't make stuff unless you don't have demand. So what is the accurate demand from the customer side? Then we need to model the network. We need to optimize the network. And then more importantly, we got to think of the outputs and getting the outputs in such a way that we could impact the operational planning. What does that mean? What is that consumable layer? Is it a dashboard? Is it an Excel report? And how do we get the information to the people that need it? And we need to be able to repeat this thing. And that's why organizing a CEO's vision in terms of a playbook or an initiative or a roadmap, I think is step number one, really critical to justifying the investment in the data function at an organization. And we've seen returns on a lot of cool little data projects that we've done, like $1 million here, $30,000 a week, just saving, optimization costs here. So there is money on the table, and this is with, some large corporations you would think have already buttoned down a lot of these processes, but people are busy. They're dealing with a lot of day-to-day sort of operational tasks, and they don't have time to step back and think of the larger picture. And when we think of the flow of goods, specifically in supply chain, and I mapped this out, not that I'm even a supply chain expert, by the way, I come from like a physics background, but when I think of what people are really trying to do and map the flow of goods, for example, they purchase some supplier, they make something, and then they have to like distribute it out to warehouses and distribution centers like Amazon does. And then it goes to the customers, and sometimes you even skip the distribution centers and ship directly to the customers. This is what Amazon does a lot of times too. And it's all driven by demand. And you think of the flow of goods through here, and the fact that everything costs money to get a product, to hold a product from step A to B to C. And the real goal of a supply chain problem or of an operations team is to minimize the cost of getting goods from A to C, basically. And everything costs money. So taking in a product and processing it and putting it in your warehouse costs money. Storing a product in a warehouse costs money. So we want to minimize essentially this process. And in physics terms, that's great. All we do in physics is minimize energy. It's really all that science really came down to for me. And I thought, wow, this is great. And it's really rich area for answering like key business questions that we would get. And those key questions lately have some themes. And number one theme is like, what is my demand? Can I come up with better demand forecasts? Yes, we'll talk about how to do that. Recently, it's not which statements will be late, it's which shipments will be late. Late shipments are pretty critical. A lot of companies that ship into big box retailers, like if you make a product, you ship into Walmart, and if your product gets there late, Walmart will fine you. So big box retailers, a lot of retailers flexing their muscles to get companies to like ship in, and manufacturers and CPGs are feeling this pressure. So predicting which shipments will be late or not is actually a really hot topic problem we've worked on recently, and that's great. That's machine learning, and it's a really fun problem to work on. And then overall is how can I reduce my network cost? Well, that's an optimization problem. It's not even like fancy optimization. It's like linear optimization. I had to learn how to write down linear equations a lot better, but it's a really cool class of problems that give you an overall ability and a playground, as we'll see later, to really impact the planning cycle. So what's step one? How do we, for example, enable any organization to do any of this? And keep in mind that although a lot of companies do invest in data science teams and analytics teams and IT teams, a lot of analysts that really deal with the day-to-day of the business are not quite there yet. They're like Excel level people, they're business trained, they're not coming out of Stanford with a PhD in computer science. So tools can help. And it's not just throwing tools out there and hoping it sticks, but there's some tools that can help, especially in the machine learning and advanced analytics space, that touch upon several pieces and almost an end-to-end of the machine learning lifecycle. right? And there's some platforms now, I think in the data science space, that do data integration, do the modeling, to the deployment and model monitoring all very well. It's not like I have to write like tons and tons of Python and scrape APIs from cloud tools in a disjointed way anymore. There's a lot of great tools to help even data scientists scale and do a lot of the machine learning lifecycle elements very quickly in a efficient manner. Because if we focus on where the pain points are, it's not in the modeling. Modeling is the fun part, right? This is the part where we all like write the notebook in and it feels so great. But the pain points are on data access and integration, and then on the other side on deployment and getting it to actually work. And if we use tools, and some of these tools, you can, we'll mention them later, but there's like the Alteryx and the Data IQs of the world, the SageMaker is kind of getting there, Azure ML Studio. If we use tools, then we could start to template processes. Templates mean governance. We could start to share knowledge. We could start to scale out capabilities of the team. If we can reuse templates and code, we could be a little bit more precise, right? We can give data scientists better ways of scaling their capabilities, trying more models. And a lot of the platforms are already going to this, the AutoML features and hypertuning and all of these things. So tools help if they're rolled out and managed in the right way. And the more of these capabilities are baked into the tool stacks, the less it falls on the individual data scientist or engineer to code them out. So here's an example of the first sort of problem we get asked, and it's like, can you build better or more granular forecasts? So a lot of companies say, well, I have 1,000 products and I sell them into all of these stores. Can you make a forecast for each product in each store? Yes, we can do that. My first question is, why don't you have that already? Like, never mind, that's a different issue. But the requests are coming more from the business side because they have to plan like allocations. You have to plan what's going to this store, what's that store. And usually the requests are coming from like business people. So how can we enable a forecast function in an organization in such a way that it's kind of governed, reusable, and kind of run from the business side? Because a data scientist, while there may be one or two in the organization, cannot run these every week at scale. There's analysts to do this. So how can we enable people to build better forecasts coming from requests from the business side? And here's an example, and we get this all the time. This is a common thing. So I'm not going to talk about exactly who this leading durable goods distributor was, but it was basically like, make me 1,000 forecasts a week type of problem. And we said, okay, so here you are as an Excel person doing great things with data. You understand your data, you understand your business. You just can't build forecasts. And there's some platforms where you can build forecasts. There's AWS forecasting, they're called Profit Library for you. I can do a bunch of things. But they can't do it. I can't give them like a Python code to like press enter on the computer to do it. I can't like monitor what they're doing and all kinds of things. So here's where rolling out a platform helps. In this case, we rolled out some Alteryx. Alteryx is like a automation platform. The gentleman from UiPath mentioned it. It was already in the business with some forecasting capabilities. We built like basically a function around that, a forecast macro, it's called forecast factory, which is a common thing, that allowed them to essentially run governed workflows, plug in their data. It would do things like check data quality. Some of the things we do for forecasting and get a better forecast is a little bit of signal processing cleanup, like take out little wiggles and some of the jitter and historical data. We'd run different models and pick a different model for each product, account level granularity, and essentially just give them the result. And they'd be able to run this. We give them the machinery, but we would package it up in a platform because then we could track who runs it, why, how, what data went through it. We could create sort of a governance log around it. And using this, the analysts were able to go pull their data themselves from Nielsen, wherever they're getting. So we couldn't even access the Nielsen data. It was like they had to go download it from Excel, which is also another blocker. But they were able to download it, just keep it, on the shared drive. And we gave them a machinery to sort of run the forecast themselves. And that's great. So tools help, but there's a structure around tools we'll get to in a second. Obviously, you can't just throw a tool at people without training and change management and keeping track of governance with, that isn't incorporated in deployment like this. And we look at like last year's, data science magic quadrant. Apart from like AWS and Azure and Databricks, like Alteryx is way up there to the right, and then there's Dataiku and IBM and SAS are still always in a lot of the companies we work with. Use tools and platforms to help build out some of these functionalities that business can access. Okay, and it helps us templatize a sort of process. If that's small, I apologize. We can Google data science magic quadrant, right? But the big players we see in the space, in terms of being able to templatize and go deliver quicker time to value and deployment and market of capturing the full ML lifecycle. So really like SageMaker's kind of there, ML Studio's kind of there. Databricks is definitely there for more technical users, but for business people, business-focused Excel level people, it's like Dataiku, and then Alteryx sometimes, which is a different conversation. But these platforms are really starting to help democratize some enhanced functionality and capability for business level people. Step 2, so if somebody asks me, hey, our shipments are late, can we predict which shipments are going to be late or not? Yes, this is a great machine learning problem. I could take my shipments data, take my orders data, take weather data, put it all together, distribution data, and make a really cool data set that's perfect for machine learning. And that's what we did. But how are we going to use it? And that's really the point here. Like, think about how a business person is going to use the results and what's their day-to-day function. So an operations planner needs to predict late shipments so that they take action to avoid late shipments. So they need to know what's going to happen and why. And their action needs to be something like reallocate supply or shipments to another company, call in more trucks. Like, what's the action that they need to take at the end of the day? And they themselves may not even be able to know all of the market conditions available to them to actually solve the problem. So things like, hey, I'm going to call another distribution company, and they tell me, oh no, I don't have any trucks available, or I only got 2. And it's a very fluid sort of problem-solving process. It's a very interactive, human-based problem-solving process. So how can your little model tell them, yes, this shipment's going to be late, you better do something about it, but it would be great to give them a little playground on that shipment to figure out like how to take the next best sort of source of action. And this involves building an application layer on top of your models, right? So if you expose a little web interface for people with sliders, little input parameters, they can adjust up and down. And if your model becomes a little playground or simulation of real life, that's the insights that people need. Because there's some market knowledge that's not in the data. So they would know, oh, you know what? I know this distributor's like, their gas prices gone up. So they can move a slider up here and there and influence the direction or the scenario of the results. And we found this is like a really critical function to support with any modeling exercise. The model is fun. You can deploy the model, but to really get it in use in a planning situation in the day-to-day life, you have to start thinking about that application layer on top of the model. Some tools have that built in. Sometimes we have to custom build something in Flask that calls like the model and an endpoint. We could get fancy, but when you think of like how can a business or an organization support like an application, you think of the roles required, just sort of the data science part, but now we're starting to add application support, and it was like coaching people on how to use like an interface and things like that. The function of the data organization starts to grow beyond just the analytics and doing like cool problems and doing the machine learning really well, right? And if we really want models and these types of approaches to stick, we got to give people the right interfaces, and application layers require the right level of support. So what am I really saying that we're building towards? We build towards a center of excellence. And some of the people in the previous talk were asking, like, well, what, how do we sustain sort of the training that we've done on SQL, or I taught somebody how to use Alteryx? We found it never stops. It becomes part of the function of the executive data team or organization we call the analytics COE, or Center of Excellence. And that's one of the things we have to do continuously in the organization and the business to get solutions and analytics to stick and to make data matter. So along with change management, they have to instill governance processes and charters and policies, because somebody else was also asking, like, well, how do I, what if I got too much data and I'm not making the right decisions because I'm on information overload? That's part of the executive function of this COE, and it's a marriage. You can't just be, IT and business and, the data scientists are off doing something else. Everyone has to be part of this organization. It has to have the right steering committee. You have to have the right meetings. There has to be a data council, and they really have to touch upon responsibilities, I think, that go from change management and end user support all the way to making sure the machine learning is running great. And it's bringing people together at the table. So when we think of like standing up an application, I don't think you could stand up an application in an organization without having governance and change management, an application team, and an engineering team, and the business team coming together, all working together to understand how it's going to be used in the day-to-day. But if we really want models to stick, that's basically our solution. And for this late shipments example, that's what we did. We got some data, we built a machine learning model to predict on late shipments, and the funny output was, it was in Excel, but an Excel that came from an output where the users were able to tune and input some parameters like change, regional gas prices or freight or truck utilization rates, because those were important parameters and they were fluid, and it was not something that we could totally pull or know from the data, especially when we're trying to plan for future scenarios. And something like that is hard to stand up and repeat unless we have like kind of a concert of business, IT, and data science function working together. And it doesn't mean, like, going back to this picture, that you need like 16 people here. Like, some people could cover multiple of these zones, right? And as your use cases, maybe you just start with 3 people at first in your COE, maybe it grows to 4 and 5 and 6, right? So this is a capability and complexity that grows over time, but these are some of the roles and requirements that we need to stand in place just to roll out an app. So yeah, we rolled out a late shipments app. We reduced late shipments by 40%, which we think is great. But really what we found were that managers were just pushing back all of their shipments out. So yeah, they didn't want to get fined by Walmart. So they just like pushed their lead times up like crazy, which is also not exactly the intent. So we had to like manage it back and create a little bit more standards around this. But it was a way in which we could get models being used in the day-to-day planning. You don't know like what this future is going to hold, right? So you have to give people a playground and a sandbox to explore different scenarios on their model. And lastly, before we move on, my favorite, we got to solve problems that people understand. So we learned this a little bit the hard way, but a less accurate model that people understand is a lot better than a really complex model that's hard to explain, okay? So if you can avoid using a recurrent neural net to solve like some crazy problem and it works fine with linear regression, go with that first approach, is basically the story here. And the ask here in a lot of cases is to optimize the network. So network optimization, there's softwares to do this, but sometimes we get asked to do it for whatever reason, in a custom way. So we're building a linear optimizer, not like, so like I learned that in first year business class, right? Optimize the network. But in reality, when you have thousands of customers and hundreds of distribution centers and you're trying to optimize 5 years out in the future, you all of a sudden have a linear system of like 100,000 variables of different costs coming from everywhere, like I mentioned, and the scale of that is not easy to handle. It's not easy to code up, and the constraints along with that, you can't have a certain amount of inventory here, and your throughput through the system has to be constrained because you can't pass, you can't ship infinity boxes of stuff through your network. There's constraints everywhere. And the complexity of those constraints and coding them up is really fun, but a very complex sort of process to bring in the data and the cost from all these different systems and put it all together. But at the end of the day, I just had like a 50,000 by 50,000 matrix. I was using GLPK and visualizing some of the results in Power BI. If you don't know what GLPK is, it's a standard linear optimizer sort of solution available in Python, R, and a bunch of languages. And that was great. So we built a model in some cases that could predict here, oh, you should close one distribution center down because its lease agreement was coming up and its operational costs, and the new lease would be too high, and it opened up another one, and it transferred all the shipments to that other one, and it made like crazy decisions, which was great. And we could tell, which zip codes were affected and how many, boxes to hold at any given month. It was a really cool solution. And then nobody knew how to run it. So we left. We're a consulting company. I'm not going to work at this company for ages, right? We did our projects in 8 weeks and we were going to leave. And then nobody in that organization could really understand. It was their model too. They taught me how to write like better constraints and linear optimization constraints and equation, but they couldn't manage all the data coming in, and it was extremely difficult for them to communicate to their managers what was going on. Right, so this was a complex model. I mean, simple concept, linear optimization, but complex in terms of its scale. And we had a big problem. So they were like, we just spent a lot of money with you guys, not a lot, because it was like 8 weeks project, but we just spent all this money, and it's hard for us to get useful results out of it at the end of the day. And I would say, yes, I told you that in the beginning. Do you really want to do this? Is there a simpler way? And in fact, it turned out there was a simpler way. So we built a heuristic model. Instead of getting so precise and detailed, we made one assumption that what you ship in and purchase through your whole supply chain is what you have to ship out. So your inventory sort of stays constant. Because yeah, it fluctuates up and down like realistically, but come on, just like assume it's pretty flat. What you need to like put in is what you ship out. And that allowed me to build in Power BI almost like a little simulation of what was going to happen based off demand forecast and things. And that turned out to be a more useful sort of entry point, one to validate data, one to understand the network and the data coming in, but also to communicate and hypothesize what was going to happen. Because our model was making decisions for sure, but it was hard for us to validate, is this right? Does this make sense? Like, how can I sanity check these things? So we built a sanity checker using a simpler heuristic model. So find that approximation, and physicists are great at this because they're lazy. They don't want to solve complex, mathematical problems. So they'll find a much simpler way to approximate a solution to a complex problem. And in this case, in supply chain case, that little approximation was just assume what you have to purchase is the same thing that you have to ship out. Our inventory was like roughly flat and constant throughout, the whole time. So that allowed us to like build out and sanity check a lot of the answers. And actually our model was making, making sense and making good decisions based off once we saw that. So we relaxed that constraint slowly, but that's sort of the gist of the talk. So if you want to solve real problems, they can be complex. So give the people the tools they need, build towards an analytics function, but you don't have to go machine learning crazy, analytics crazy. Solve business problems, right? Solve business problems, and sometimes that means taking a simpler approach that people can use. So 80% of a simple solution is better than 100% of a complex solution in most cases if it can help you get there faster. So thanks for your attention. I just wanted to leave you with those thoughts and hope you learned something today. All right.